While handheld tools can quickly and accurately measure the dimensions of a part, the size, complexity, or quantity of parts often require the use of larger and more advanced measurement equipment. We make use of some of the most advanced metrology systems available in order to inspect and reverse engineer parts with high amounts of accuracy and efficiency. A height gauge is used to measure the linear distance between features on a part. Its fast operation makes it ideal for quick inspection on multiple components. Multiple probes allow flexibility in what features can be measured, such as small or hard-to-reach surfaces. Extremely large parts can also be measured, depending on the size of the gauge. Digital gauges can connect directly to computers for quickly capturing and analyzing large amounts of data. A coordinate measuring machine, or CMM, is used to measure the location of individual points in 3D space. A probe with a hard tip, such as sapphire, makes contact with the surface of an object to measure its location. The versatility of a CMM makes it ideal for measuring objects with large amounts of complex geometry. On a manual CMM, an operator moves the probe by hand, controlling individual axes of motion independently. Setup time for a part on a manual CMM is minimal, and programming is not required, making it a quick and effective way to check the geometry of parts in small quantities. For an automatic CMM, all degrees of motion are actuated electronically, including probe orientation and tool changing. Movements are programmed by an operator and can be iterated any number of times. With proper setup, this allows large volumes of parts to be quickly measured and inspected. Post-inspection, reports can be automatically generated and saved for future quality control reference. Video inspection systems utilize magnifying optics to produce an undistorted image at a known size. This means that the dimensions of objects in the image can be measured accurately in very fine detail. Video inspection systems are especially useful for measuring parts with geometry that is awkward to measure on a CMM, or whose shape may change when pressure is applied to them, such as a rubber O-ring. Some systems even have the ability to automatically identify geometric features. Center testers are utilized primarily for inspecting variation on cylinders with multiple diameters. Typically an analog system, center testers are easy to set up and utilize two indicators to measure variation around the surfaces of a cylinder. An operator uses these readings to compare how one surface deviates from another. 3D scanning technology is a powerful tool used to digitize the surface of any object. There are many methods for 3D scanning, but we utilize a laser scan arm with an accuracy of 75 micrometers. Paired with powerful analytical software, 3D scanning allows for detailed part inspection and streamlined reverse engineering.